afternoon, participants. Welcome back. We shall now commence our afternoon session. The session will be engaged by Dr. P. Nagabhushan on Introduction to Machine Learning and its Applications. Before we commence, I request Dr. Sharmila Kumari to introduce the speaker of the session to our participants. Over to you, ma'am.
Very good afternoon to all. It's my honor and privilege to introduce Professor P. Nagabhushan, who is currently working as the Director of Indian Institute of Information Technology, Allahabad, Uttar Pradesh. Professor P. Nagabhushan formerly worked as a professor in computer science, the chairman of the Academic Reformation Committee, the chief nodal officer for the choice-based credit pattern continuous assessment education system, the Director, Planning, Monitoring and Evaluation Board, Dean, Faculty of Science and Technology at University of Mysore. He worked as the Mentor Director to IIIT Lucknow during 2017 to 19. He was also the Distinguished Professor and Chairman at Amrita Vidyapeetham, Amrita University, Coimbatore, Director of Bangalore Education Society for Technology Advancement and Research, and Principal at Bangalore Technological Institute, Bangalore. He is the invited professor at University of Dauphine, Paris, France, and professor under exchange program to the Department of Computer Science, Saginaw Valley State University, Michigan, USA. He is the visiting scientist on Indo-French Research Assignment, India, and University of Dauphine, Paris, France. He is an invited expert at Michigan State University, USA, and University of Medical Sciences and Technology, Sudan. Professor Nagabhushan has successfully guided 31 students towards doctoral degree, and 5 students are currently working towards PhD. To his credit, he has 536 plus total number of research papers, out of which about 100 papers are highly acclaimed DBLP indexed. He is having 2,528 number of citations with an H index of 25, I-10 index of 72 as on 10/6/2020. He is a referee and reviewer for several international journals, conferences, symposiums and workshops in the area of pattern recognition, image processing, computer vision, document analysis and algorithms. He is on editorial board of several journals. He has received several projects from various funding agencies such as AICT, UGC, DST, ISRO and DRDO. Professor Nagabhushan received many awards including Fellow of International Association of Physical Sciences, Fellow of Institution of Electronics and Telecommunication Engineering, Fellow of Institution of Engineers, ISTE Visiting Professor, ICCR 2008 Outstanding Academician and Researcher, ICICOT 2007 Outstanding Academician Award, IEEE ICSIP 2006 Award in appreciation of lifetime contribution to the field of signal and image processing, and many more. In his capacity as a Director of IIIT Allahabad, he has initiated many academic activities including PhD, BTech and MTech assessment pattern, foreign collaborations, MOUs, etc., and has made excellent administrative reforms. We are happy and proud to present before you our beloved Professor Dr. P. Nagabhushan, who will deliver a keynote address on machine learning and its applications. Over to you, sir.
Good afternoon to all of you. So because I liked your title, Machine Learning for Societal Applications, I have retained the same title for my talk also. All right, these are my contact details. I shall go ahead. See, machine learning. This word, this phrase, machine learning, is a composition of 2 words. Number 1, learning. What do I mean by learning? Learning originates from intelligence. Learning is the word originating from the word intelligence. So learning happens because of intelligence. machine. So it implies simulating this intelligence on the machine. So simulating human intelligence, specifically simulating human learning capability. Intelligence most of the time would be referring to the learning capability. So human learning capability is simulated on the machine. So if that could be done, then it becomes a machine learning. All right. Learning can be constructive or can be destructive. In fact, many people learn have to put a larger learning to become destructive. They have got to put less learning to be constructive. For instance, the two monuments in America which were brought down by those people were because of destructive learning. So constructive learning and destructive learning. So now constructive learning leads to wisdom, and that results in societal upliftment as envisaged in your faculty development program. In your faculty development program, when you title it as societal application, you really imply that is societal upliftment. However, destructive learning would lead to doomsday, and that becomes antisocial. In fact, all my PhD scholars, including Professor B.H. Shekhar, who will be presenting the lecture to you, and then that way B.H. Shekhar was my son, and Dr. Sharmila is my granddaughter, because she was the student of my student B.H. Shekhar. So these were all wise people because they were involved in constructive learning. Similarly, whatever the work they did in their respective research work was learning, machine learning, and then that led to lot of societal upliftment. So that all leads to many societal applications. Okay, so there are two important: constructive learning and destructive learning. Of course, even if you want to make the machine to do antisocial activity also, that machine should be made to learn that. Whether it is constructive learning or destructive learning, machine will not make out any difference. Machine cannot understand what type of learning it has done, because the learning has been taught to the machine by the people only, by programmers, by the engineers. So the ability of the machine is surely because of the ability of the human brains behind the machine. That you have got to understand very clearly. All right. So a paradox in the learning paradigm. See, in machine learning, in general learning paradigm, there is a paradox. What is that paradox? Paradox is learning for the sake of just passing a stupid examination. Like we have been doing it all through our life. We learn. Learn for what? Learn to complete one stupid examination. It can be joint entrance examination, or it can be common entrance test for admission to BTech or for admission to MBBS. It can be NEET. So these are all only learning for the sake of passing an examination. Then afterwards, we learn to pass first semester, second semester, like that. Somehow we learn to complete BTech. But have we learned for BTech? That is secondary. But we have learned how to pass an examination. This learning is not really a good learning. In fact, people do not seem to learn anything from this type of learning. They don't learn anything, right? But on the other hand, they depend upon memorization, rote learning. Okay, so because they have got to pass an examination, because that question appears quite often in the examination, and that's what we want to learn. So it is a rote learning. It is memorization. Well, you should know that the very first version of machine learning was also based on this memorization concept only. We made the machine to remember the rules. We made the machines to remember cause and effects, and that table of cause and effect, the database of cause and effect, were loaded in the machine, and machine definitely memorized all of it. Naturally, if it is available in the machine, it is equivalent to keeping it in the memory, and machine would do a search, and then how quickly one could access the solution was the success of the then machine learning. The very first generation of machine learning was also like what we had we have been doing in for our examination, the memorization. But today machine learning has evolved into a different level. Today machine learning has gone to a level where it could almost compete with the learning capabilities of the human being. However, even if I tell that it is competing with the learning capabilities of the human being, you should clearly understand that it will be in one particular domain. Whereas human beings' capability could be in multiple domains, in several domains. His learning ability, his intelligence is multi-pronged and multi-dimensional. Perhaps one code or one machine, one application cannot be able to really simulate the human intelligence, all-round human intelligence. Just recently, I was reading some article in which it was told that the machine learning the capability or the machine intelligence is not even that of a second standard student. That is all at the most today. Today's machines are up to the ability of a second standard student, second primary school student. So that means you are all so lucky, you are all so young, and your students are youngsters. They have long way to take the machine to high school level of learning, and then to the college level of learning, and then to PhD level of learning. So machine learning has a larger scope. Okay, this is popularly, whatever I told you, memorization is popularly phrased as preparing for examination. You ask anybody, you ask parents, what is your son doing? Your parents will very proudly tell, my son is preparing for common entrance test. My son is preparing for NEET. My daughter is preparing for NEET. And similarly later, you ask the question, what is your son doing? What is your daughter doing? He is preparing for himself for a job. That's the next preparing. And then you ask the same question, then the parents will proudly tell, my daughter is preparing for the marriage. My son is also preparing for the marriage. This is preparation. The life itself is full of preparation. There is no way to appreciate the value of life because you end up only preparing for life. Preparing does not imply learning at all. But however, as I mentioned just now, this type of preparation was the first version of machine learning. When we started our life with artificial intelligence and our life with the machine learning was something very similar to this, but now we have evolved over time. Of course, now it is time for me to retire from all these things and listen to you people. But still, let us continue. So now next is intelligence. I told you learning is because of intelligence. What is intelligence? Intelligence is the ability to acquire and apply knowledge and skills. Some people acquire knowledge, but they are not able to apply knowledge at all. They just acquire. They are storehouse. They are the hubs of knowledge, but they don't act wise at all. The people who do not act wise are very knowledgeable. They have acquired knowledge, but they cannot apply knowledge. So when they don't apply the knowledge, then they are not intelligent. So intelligence is both acquiring and applying knowledge and skills, both of them. You should skillfully apply the knowledge. That is more important. In fact, in morning session, I have told what is skill. Skill is the ability to transform the knowledge into real life, into performance, into action, into a product. So that happens because knowledge is applied. First, to do that, knowledge has got to be in your list, and that has got to happen only by acquiring the knowledge. All right. So now the capacity for logic. What is intelligence? It is the capacity for logic. Okay, you just understand every word which has been carefully chosen. It is a capacity for logic. Many people talk very illogical. If a programmer himself is very illogical, what type of logic could be possible in the code that he writes. So the machine has got to be very logical. If machine has got to be logical, your intelligence should be very logical. Okay, so the capacity for logic, then the capacity for understanding. So this is the important part of intelligence. Intelligence lies in understanding, lies in not only understanding whatever you have studied, but also in understanding others. We should be able to understand others. We should be able to understand ourselves. So capacity for understanding is intelligence. So machine should be able to do that. Can it understand the scenario? Can it understand the situation? If today machines come with sensors, today machines come with the interface of cameras. The moment the camera can look at a student, and can the machine understand that the student is not in a good mood today, therefore I should show a very nice movie to the student to start with. Then once his mood becomes very good, then I shall start with machine learning, or I shall start with artificial intelligence, or I shall start with teaching him one lesson on one unit on compilers, like that. So can the machine do that? Can it, the moment it sees the face of the student, then it should be able to decide, today now I should run a cartoon movie for this boy, and then gradually build up his mood, and then I should come to teach him a lesson. That is what is understanding, the capacity for understanding. Can the machine do that? So self-awareness, the capacity for self-awareness is also is an important component of intelligence. The capacity to learn, that is what, learning, understanding, they all go together. The capacity for learning is intelligence. The capacity for emotional knowledge, emotional stability, emotional knowledge is intelligence. So you should be emotionally controlled. That's what people tell. You should not exhibit your emotion. Emotionally controlled. That does not mean that you should not have emotions. You should have emotions. One should have emotions, but one should be able to control the emotions. More than controlling, you should not do an exhibition of the emotion. So can the machine do that? If can we code the machine to simulate this aspect? So the intelligence is in reasoning. So naturally, logic and reasoning, they go together. Understanding, logic, and reasoning. If you understand the logic and learn the background, then you will definitely give the reasoning. So reasoning is the intelligence, and given a situation, the machine should also be able to reason out and take a decision. So the reasoning is a part of intelligence. Planning. So once you have a reason, once you have understood, then naturally you will plan the execution. Like in the example just now I told you, the machine will first decide that let me run a nice movie for this boy now for first 20 minutes. Then after the movie, then I shall start chatting with him. How are you? How is your mood, etc. That's what is the planning. The capacity for planning is intelligence. Most important is planning. Planning, the ability of a candidate to plan the thing based on learning and based on understanding should be the assessment. In fact, the intelligence has got to be assessed. Unfortunately, our examinations do not assess the intelligence. They assess only memorizing capability, that is preparation capability. How well has he prepared for examination? Not how well can he plan to write an answer in the examination. Okay, so planning, capacity for planning is intelligence. Creativity. So how creative am I? It is not just reproduction. It has got to be creative. Creativity comes from reasoning. Creativity naturally comes from a very good learning. I shall not use the word deep learning. I shall tell that committed learning will make you to become a very creative person. Creativity. All right. Critical in thinking. So creativity and criticality should be together. In fact, my interesting phrase which I normally use is, One should be creatively critical and critically creative. Critically creative. You must be a critic. The critic doesn't mean that you should hurt somebody. You must be critical in thinking. Okay, why, how, when, where, all these things should have been tackled by you. See, why, when, where, how is criticality, and that leads to a very good planning. Very good planning happens because of very good reasoning. Very good reasoning happens because of very good self-awareness, and very good self-awareness happens because of a respect for learning. And when you learn, understanding happens. Understanding results into creativity and also into critical thinking. So in all, the intelligence is in the capability of solving a problem. Given a problem, can you plan a solution? Can you design a solution? That is what is algorithm design. It is not coding. Coding is the last part. Algorithm design is more important. Okay. Therefore, learning the problem is important. Learning the problem, reasoning, planning, and then that all put together will become problem solving. So intelligence refers to the capacity to solve any problem during any situation. Can the machine also be able to simulate this natural intelligence of the human being? Then can the machine learn on its own to do that? Okay, so artificial intelligence is a simulation of human intelligence in machines. In fact, the phrase artificial intelligence has become very popular, has become very catchy, but unfortunately, it is not the correct representation of the subject. It is not artificial intelligence. It is simulation of human intelligence. It is, in fact, you have got to emulate, you have got to perform like human intelligence. Artificial intelligence is only an artificial replacement. For example, in an accident, if one were to lose a limb, then we don't get a natural limb. The limb will not grow, the leg will not grow again, the hand will not grow again, but they can put an artificial limb over there. It may not be able to function, perform like a natural hand, but still it is just a completion. It gives the visual completion. It can do some activity by controlling, by external controls. Therefore, the intelligence lies in external control. So that is what is simulating the intelligence. But the hand by itself is artificial. So you should understand the meaning between the difference between artificial and simulation of the naturality. But artificial AI has become such a buzzword. We have all accepted. But then the artificial there does not really refer to the intent with which we want to simulate intelligence. Okay, simulation of human intelligence in machines, which ultimately leads to machine learning. So nevertheless, we shall come back to preparing. Even preparing has some advantages. The initial way of putting our intelligence in the most minimal way, without really utilizing the entire part of brain, we can still be in one way, in small way, we can be intelligent. It is because of preparing, like we prepare for examination. And those who prepare for examination only will get more than 90 marks, more than 95 marks, which should not mean that all those who get less than 70 marks are very intelligent and therefore they got less than 70 marks. It is not that meaning. So preparing is make ready for use or for consideration. Make ready, keep it ready. That is what is preparing. Like I have prepared these slides. So I got to prepare these slides with the help of my personal secretary because I have got to make the presentation today. Like prepare the operation theater. A surgeon will immediately call the head nurse and ask the head nurse to keep the operation theater ready. Then we can take the patient and perform surgery. That is what is preparation. Prepare the dining table. Suppose you have invited a guest, then your spouse will be very busy in preparing the dining table, in preparing the food. Okay, so in preparing, that is preparing. Now, just in my earlier talk I was telling you, we prepare for JEE, we prepare for NEET, we prepare for GATE examination also, prepare. For that matter, we prepare for IAS examination also, prepare for public service exam. So these are all prepared engineers, prepared administrative officers. These are all made. They are not learned. Okay, learning is entirely different. Knowledgeable, being knowledgeable is entirely different. Okay, and then preparation tells what to answer. Should please note it. It is what to answer. Like. Like tell me what is that when uncle and aunt come home, you will call your child and ask him uh, what is the what is the name of the first president of India, what is the name of first president of America. So these are all mucked up. What learning? Memorization. There is nothing. And don't call such children as very intelligent children. Don't project them that they are very intelligent, because they are made to prepare. They are made to by heart. So it is what to answer. It is like parrot answering the question. What to answer. Okay, preparation is what to answer. So it is perfection in replication. It is rote learning. It is perfection in duplication or in replication. It is rote learning. Or it is mathematical. It is a lookup table, LUT approach, a lookup table. So there is a lookup table, like a bank clerk will look into the lookup table and tell you how much your so much of money will earn the interest. That is what is lookup table. It is memorizing. It is an art. Preparing is probably an art. Okay. All right. So that is what is preparation. And note that initially we had our machine learning, which depended upon this preparation. On the contrary, learning is the process of acquiring new understanding. Okay. It's not merely understanding, a new dimension to understanding. Learning is the process of acquiring knowledge. Learning is the process of acquiring behavior. See, naturally, if you are a learner, if you have learned very well, your behavior traits will also change automatically. Your learning is the method of acquiring the skills. Learning implies learning values, learning attitudes, learning preferences. Okay, this is learning. Learning is the ability. It is not the ability to by heart. It is an inherent ability. It is an ability. It enables devising a solution to a problem. It is not what to answer, but it is how to answer. Okay, how should we answer? It, in contrast to what to answer, this is the ability of working on how to answer the question. So creative understanding requires assimilating. First you should gather and you should assimilate. Then you should internalize. So one should internalize and then inculcate. It should all become part of your brain, not part of your memory. It has got to become part of thinking process. Why am I spending so much of time? That is what ultimately machine learning has got to do. The type of codes for machine learning that you write should be able to do the training, and that's what we call it as supervised training and unsupervised training. And tomorrow and day after tomorrow, all the other experts, probably Professor B.H. Shekhar, Dr. D.S. Guru, all of them, and including your team research, all of them will speak on this. But they are the models you should understand for assimilating and then internalizing that knowledge, and that knowledge becomes a part of the system to take the future decisions. Okay, I will just give a very simple illustration which is from our day-to-day life. Okay, very simple primary school example to show the difference between preparing a lookup table approach and using intelligence. Look, I shall ask you the question, what is 7 plus 7? When people are very smart, they will immediately tell 14, which is a lookup table approach, which is from memory, straight from memory. 7 plus 7 is 14. On the other hand, what anybody would do, an intelligent person would do, 7 plus 7 will be equal to See, 7 to this 7, I should add some part of 7, so that it becomes a interesting intermediate stage. For example, one intelligent person may do like this. He may split 7 as 3 plus 4, because he knows that if he adds 3 to 7, it becomes 10. That's a very lovely intermediate point, because once it is 10, adding anything upon 10, above 10 is very easy. I can easily add that. So 7, so I shall split the remaining 7 as 3 plus 4, because 3 added to 7 gives a very convenient intermediate state. So I shall change that 7 plus 3 and then 4, it becomes 10. 10 plus 4 is 14. This does not require memory at all. You need not memorize. You can use your intelligence, plan a method, understand, plan a strategy, and solve the problem. Simple. That's all. So now I have got to teach the machine to do this planning, not to do 7 plus 7. If you write a code for 7 plus 7, it is okay. It is simple coding. But then you teach the machine itself to recode itself and find its own code to find out 14 given 7 plus 7. Now I will give you little more tricky example. What is 7 plus 9? Any intelligent person would first convert it into 9 plus 7, because 9 is closer to the intermediate point 10, not 7. So 9 plus 7. So once 9 plus 7, then the remaining only 1 has got to be added to 9 to make it 10, which reduces 7 to 6. That's all. So 9 plus 1 plus 6 becomes 10 plus 6, it is 16. So this is the intelligent way of planning a solution, whereas 7 plus 9 trying to go in the memory and searching, finding out the answer from, as if you're finding out the answer from lookup table, is not really learning. It is preparing. Okay, so that's a very simple example. You should be able to understand that. So what is machine learning? Machine learning is the application of artificial intelligence. Artificial intelligence, as I said, is not the right word. It is the application of intelligence, and it is intelligent computing. Therefore, machine learning ends up in intelligent computing. Okay, all right. So that provides, please note this very carefully, that provides systems the ability to automatically learn. So who is going to provide that ability? Again, a set of code only. You should be writing a set of algorithm. You should be designing a set of algorithms which will provide the ability to the machine to automatically learn, and another set of code, another set of program in addition to this program, which will improve with experience. See, more and more I get experience, I would have learned more and more in life. That is why there is no substitute for experience. So it improve from experience. The system should improve from experience without being explicitly programmed. So it is not explicit coding, but it is implicit coding. It is implicit algorithm which makes us to automatically learn, and which makes us to automatically improve our learning outcome along with the experience. So we have got to now design algorithms at very high level, which probably sounds like an abstract level at this point of time, but that is what is the challenge with the machine learning, because ultimately it is simulating the ability of human learning, and that is how the human would respond. Human would automatically learn. It appears it's automatically learn, but even that learning has such a rich background. So much of schooling, so much of your culture with your parents, so much of your playing, etc., would definitely lead into automatic learning, and ability of learning keeps on improving with your experience. So this is not explicitly programmed in your brain, but it happens because there is an implicit program which is running in the brain. So that is what is machine learning, and this is what you are going to learn in the next 5 days. You have got to keep on watching how different strategies like clustering, classification, supervised learning, unsupervised learning, whatever you are going to learn would lead into intelligent computing and making the machine to work at least in one particular domain. Please note, you cannot think of one machine to be multi-purpose. At any given point of time, your machine can be able to take up one application, one app. It can be handwriting recognition. It can be, guessing. It can be doing. I will be taking up some examples, but only for that app you can develop definitely a very intelligent machine learning platform. It can be for breast analysis. It can be for cancer detection. It is only for cancer detection. The machine which I learned for cancer detection, the code that has been very useful for cancer detection cannot be employed to find out what is the type of headache that you are getting, to find out what is the problem with your heart. Heart problems are entirely different. So you have got to really do domain. Domain is very important here. Whereas human beings seem to have a fair understanding of all the domains, but note that our exposure to domain has been right from our birth. In fact, in certain domains, it is understood that it is picked up by every one of us right from the day we have been actively present in the womb itself. Okay, so right from those days, the domain exposure is happening, and now the domain exposure is another important point. But naturally, we speak about one domain at a time when it comes to machine learning or when it comes to machine intelligence, artificial intelligence. So focuses on the development of algorithms and programs that can access data pertaining to one domain and use it to learn from data. So you have large amount of data and use it to learn from data for themselves. That is what like human beings would do. So that doesn't mean that machine itself can write its own algorithm. Machine itself can write its own program. To write its own program to solve a particular problem, there must be a meta algorithm or a meta program. Okay, that meta algorithm or meta program will enable the machine learning, and it will enable the machine to have the access to data, to identify, to understand the right set of data and employ that right set of data to learn from data for themselves, for consumption by themselves. That is what is machine learning. Okay, machine learning obviously can be incremental. Incremental learning goes step by step. Like I told you, with experience, the level of learning improves. So with experience, your knowledge level also goes on improving. That's what is incrementally it gets expanded. So incremental learning is a method of machine learning to which input is continuously used. As and when the input become available, more and more input would become available, more and more knowledge we will gain. So that is what is incremental learning. So incremental learning it will help us to extend or strengthen our existing knowledge. Our existing know-how would be improved. So strengthen the existing model's knowledge or to enhance the knowledge to a further level. That is what is the incremental learning. Okay. Then repeated learning, spaced repetition. This is another important thing. So we learn like we learn, and then after some time you give some gap, and then after some time again you try to learn. Then the way you understand is entirely different. Your subconscious works in a very different way. Your responses will be more improved. Your responses would be more scholarly. If I tell the right word, it is more scholarly understanding could be possible. So this is what is repeated learning or spaced repetition. In fact, my father used to tell me that he made me to read one novel as early as when I was in 6th standard. Then I read it when I was in 7th standard. Then I read it when I was in 8th standard. Same novel. Same novel again I read it in 9th standard. Now, then I had not understood why is he making me to repeat it. But when I read it, when I was again in BE, it all told me different aspects. That is what is repeated learning. It is spaced repetition. In fact, that is one of the excellent methods in machine learning. So another is today we are speaking about deep learning. Surely I will not speak about deep learning. I'm very sure somebody will talk about it. But my interpretation, you please understand, I call it as local learning. What is local learning? It is learning at the local level with all local details, giving more attention to all local details, and it is accomplishing the global objective, global goal, global target is achieved. So it is called global plus local. That is what is deep learning. And deep learning deep learning has not the idea of exact idea of repeated learning, not the exact idea of incremental learning, incremental, repeated in multiple leveler learning. So deep learning refers to global plus local learning. So now let us understand what is meant by understanding. Understanding is the ability to understand and ability to comprehend. Okay, that is what is understand. So the machine has got to should display the ability to understand. Tell me, when have you understood? People only on the deathbed they tell that, oh, I am very sorry, I did not understand you all these days. But it is too late now. You are already on the deathbed. So what is the ability to understand? What is meant by understanding? Let us just know that. How do you tell that? How can I tell you that you have understood whatever I have spoken? The ability to understand and ability to comprehend. So understanding is think about it, use the concepts, and deal properly and adequately. So you should deal properly and adequately the concept. Think about it. The ability to think and implement is understanding. Okay. So it is incremental learning. Therefore, incremental understanding will happen, which is equivalent to progressive learning, progressive assimilation. In fact, the real understanding is moving from a known end. Start from a known end. That is the start point. And then gradually build up your bridge to get into an unknown end. The discovery of the novelty. That is the goal part. That is what the understanding should lead us to. Okay. So learning, now, naturally, how learning will happen? Learning will happen by seeing the samples, by seeing the instances, different instances. Okay, you see many people, you see many cats, then you learn the characteristics of a cat. You see many dogs, then you learn the characteristics of a dog. You see different types of books, then you learn how a book would look like. So these are all from instances. Now, open the book, go through the book, then it is learning from characteristic observations. When you talk to a person, you find out how does he react, how does he talk, on what topics does he talk. These are the characteristic observations. Learning from samples, large number of samples is one aspect. Learning from the respective observations is another aspect. So the learning from instances constitutes the sample space. That is what we call it as a population. Surely the experts would speak about the importance of sample space, and they also would try to speak on the size of the sample space or the population. Okay, learning is from instances of sample space from the population. How many? So now the question is, how many samples are required to learn? How many samples are required? This is another big problem. All problem associated with deep learning people, problems associated with all learning neural network people, they always tell, I used 70% of the population to learn and 30% of the population for testing. I don't know from where they have picked up, which books will tell them, why should that be done, why 80% of the sample should be used for training, I still do not know. Okay, anyhow, I would take one full lecture on how many itself, therefore I shall not get into that. But then deciding how many samples are required for learning is a important challenge. In fact, my recent work, although I wanted to end all my academic activities and research activities, still some 2-3 PhD students are still working here with the IIIT Allahabad. Now one PhD scholar is working on how many and how to reduce the number of samples for effective learning. Okay, how many, and then which of them. Okay, how many is one part, which of them, like should I pick up Sharbila to know about Mangaluru, or should I pick up Shekhar to know about Mangalore, or should I also pick up Ganesh Pai to know about Mangalore, or can I drop any one of them? This is what is which of them is important. How many is one point. Next, which of those points. So when we speak about samples, which samples should be considered? All right. Then more instances or minimize the instances. These are the questions that people would discuss in the days to come, but I shall not get into that. But even today, these can be very open, interesting issues in machine learning. Now, other point I told you, from characteristic observations. What are those characteristic observations? The number of observations constitute the feature space. This is sample space, and every sample is characterized with the observations which are called feature space, and mathematically we call it as a dimensionality of the space. So which features? So naturally you have in your own way you might have understood what is curse of dimensionality. More the number of features, more will be the confusion also. Okay, so then how will you overcome that curse of dimensionality? So curse of dimensionality, can we accomplish it by dimensionality reduction? Can we define optimal number of features, less number of features for effective learning? That is what is the dimensionality reduction. So dimensionality reduction can be by two important methods. One is feature subsetting. Can we identify the right type of features? For example, if I have a daughter for whom I am looking for a prospective boy, then what do I look at in every boy? They are the subset features. I am not going to see whether he is a first rank holder or a second rank holder. I may not even see whether he has got a MTech graduation or a PhD graduation. Those features may not be necessary at all, because I am interested in getting a husband for my daughter. On the other hand, if I am interested in taking somebody for PhD, then I shall definitely ask a question: how good was he in his mathematics course at 10th standard? How good was he in his mathematical ability in his graduation days? These are the different types of features I would look into. So feature subsetting. Then another feature transformation. People speak about principal component analysis. Now I do not have time to speak about all these feature transformations. In fact, my PhD, those good old days, was upon feature transformation. Okay, I came out with the new methods for dimensionality reduction. In fact, Professor Shekhar, who is going to be one of the speakers, and then Dr. D.S. Guru, in those days worked very well on these aspects also. Okay, all right, they had worked very deep on the learning. Right now, I shall now take up some cases from the societal applications. Observe them carefully. Each one of them can become a very potential problem. Each one of them can be an independent project, and if somebody can think very deep upon that, each one can have a patent for himself. Okay, all right. Now you just look at this. The first, I shall take up the example of washing clothes, and naturally leading into washing machines, which are machine learning, okay, and machine in action. Okay, all right. So you look at the very first picture. What do you learn from this picture? It should not mean that your elderly mother should only wash the clothes. That should not be learned from that picture. But then what is important in this picture is that there must be flow of water, continuous flow of water. There must be enough drenching of clothes in the water. And washing requires the support, the mechanical support of the two limbs. Okay, the two limbs are used, are employed in washing the clothes. That's what you should observe that. And look at the second picture. So this is this again another form of washing only, where the action of these limbs should be observed here. It is doing both rubbing and also it is at the same time drenching. Everything is done by the same set of hands. Okay, now think how it is, all these actions are mechanized intelligently into washing machine. That has got to be what you have got to observe. All right, now real washing is that first you drench them and then apply some soap and keep it for some time, keep this for some time, right? And then you rub against it, and then surely you will be cleaning with water. Now this cleaning with water is to eliminate the soap content. The dirt is eliminated here. This eliminates the soap content. Okay, this is what is washing. Okay, now if it is heavy duty washing, big clothes, the examples, previous examples were for very small clothes. If it is big sized clothes like rug, like bed sheets, etc., or like a big coat, etc. Okay, what sort of washing will we be doing? So this is washing at a very heavy level, heavy washing. All right, and these are the examples. Finally, surely you have got to you have got to put it on the sunshine for the clothes to get dried. So drying is the last process. Okay, but then on certain clothes you would have seen that it should not be dried in the sun, it should be dried in the shadow. Some instructions would be there. This is what is washing. Now as far as machine is concerned, you have got to still put the clothes into the machine, but where are the limbs? The limbs which work there, they are the blades. But unfortunately the blades are not moving limbs like the human beings do the washing. That is the reason even today with the best machine, you may not be very happy with the type of washing that would happen with the machine. Why have I taken up this example is, can you really invent the machine which really simulates the washing action done by expert human being in washing? Okay, so this is what is the washing with the washing machine. And here of course there are different types of washing machines, but the blades and rotating of the blades try to simulate the hands rotation. Okay, try to simulate that. All right, and then what would happen, see, these are the blades, and then what is going to happen? It is centrifugal and centripetal activities on the cloth, which is churning of the clothes, and then you have seen what happens in the washing machine. All of them get assembled to one point because of that the rotating activity. All right, and then of course you will pull out, and when you pull out, you have seen what would happen to your clothes. Okay, all right. Then we will transfer it to another bowl called drying part of it. So next is drying part. So machines are available for drying. Okay, and then it is the mass drying system or huge washing machine setup. Now you observe this picture. This is again in continuation with washing only. What is this lady doing? She is observing carefully the specific parts in the cloth where specialized attention is required in washing. That is the real learning. But would today's machine do that? We speak about fuzzy washing machine. We speak about many sensors in the machine. But can the machines do such an observation as this lady is doing here, looking at the collar? All right, see here, looking at the collar. All right, and see here, what do? We do a special care, special attention to the collar, special attention to the special places. Apply soap. Even now with the washing machine also, some people do it and then put it into the washing machine. Then it is not really total machine doing the job. So machine learning has not been totally done at all. Then after observe and then selectively do, and then you give the personal attention, very personal customization of washing. Every cloth needs a different type of washing treatment. The undergarment, the way you wash your undergarment is different from the way you wash your shirt. The way you wash your pant is different from the way you wash your baniyan. So these are all very specialized, customized washing. Have you been able to think of such a washing machine? And can we incorporate such learning ability on the machine? The machine, the moment it picks up the next cloth, imagine now the whole washing machine to be a pipeline. And imagine one cloth comes over there. And you should now immediately understand, recognize that this is a pant. And this is a colored pant. And now where all it should look at, for customized, for focused attention in the pant. Where will be the possibility of dirt in the pant would be more? Where is that? Can we do that? So if one can definitely invent such a machine, and for inventing the machine, it is not the mechanical part of the machine which is important. Mechanical part is also important. I am suggesting the whole washing machine cannot be one unit. It has got to be a pipeline, where on the belt, where on the pipe, the cloths keep moving one by one, like in this picture. One by one you make the observation, and for every observation you have a special particular treatment, and that particular treatment comes from your brain, comes from your knowledge, comes from our intelligence. It has got to be case made. It cannot be a rule. Or if this is this, do this. It is not that. It comes from out of your experience. So your washing machine algorithm should be like that. Okay, and the whole design of washing machine has got to be different. And finally, you see here, it is customized washing, case to case. A different type of rubbing, different type of cleaning has got to be incorporated. Then naturally it goes through the phase of washing, and then it goes through the phase of drenching, drying. It should happen. Can the present washing machine is just only one cylinder? All right, and that is the reason why you are not very happy with the washing machines, whatever is washed by the washing machine. Okay, because this personal treatment, personalized attention to every cloth is missing. So that is the high end of machine learning. And obviously, I have taken this example to illustrate how even the simple things like washing machine, still, although we have got very different varieties of washing machine, the minor details, the minor scopes of intelligence, how intelligent washing has been done by a human being, has not been incorporated in the machine even now. Even today, it can be a very big, very interesting open problem. That is what I just wanted to convey. All right. Next, I shall take up the next set of examples with regard to text document images. You look at this text document images. Okay. So what do? When we look at a text today, we don't we just take a mobile camera and take the picture of the text, because we cannot write down, we don't have time to write down, we just take a picture using the mobile camera, right? Now once I take the picture of mobile camera, then what should be my concern? My concern is I don't want to read it again. I would just plug in a earphone, and my mobile phone should be able to read the content into my ears, so that leisurely I can read, I can listen to, or simulate reading by listening to. And who is doing the reading activity? My mobile should do the reading activity. From where should it do the reading activity? From the document which has been captured as a photo, as an image. It has been captured. Now, what are the problems associated with that? Naturally, the problems are a document is not just a running text. A document has got a diagram also, and there shall be quite frequent referencing to the image, to the diagrams when the text document is read. Whereas, while a human brain reads such a document, wherever there is a reference to the image, automatically our eyes will get onto the image and will try to collate, understand, and establish the connectivity, establish the relationship between the text and the diagrams. Whereas now, if my target is that I should automatically close my eyes and still automatically listen to the contents, can that be now made possible? Can you automatically visualize the diagram also when you have closed your eyes? That's the real machine learning. You try to do that. Okay. Then look at this part. The point is, your mobile is such a small device, and you cannot contain the picture of the entire document in one go. Then you have got to move the mobile from one end to the another end, like this, from one end to the other end. Therefore, it now is not a document image, it is not a document text image, it is a document text video. It becomes a video. So from the video, how will you construct one image? That is, from a video, how will you construct one document file, one image, so that so that your own mobile can comfortably read it into your ears? So that is the next interesting question, right? That's what you have got to do. In fact, one of my PhD scholar worked on this. Okay. And other point is this interesting point. See here, how is this mobile held? The mobile is held very perfectly parallel to the plane containing the text document. And this perfect parallel plane should be maintained. All right. Unfortunately, we cannot maintain that. We may hold it at some particular tilt, orientation. All right. Will you see? Tilt, orientation, shaking of your hand, and then purposeful movement of the mobile from one end to the another end to capture the entire text as a text video, not as a text image. Then the whole thing should be converted into a text file, and then I should be able to, not I, again machine should be able to read that text file into my ears through the earphone, connecting earphone, and I should be able to understand that. This is what it has got to happen. So this is the real challenge of machine learning. Machine has got to see learning. Reading is the target. What reading has got to do? It has got to capture the machine. Yes, images. Image cannot be possible. Video. So from video, will you get an image? And then when video grabbing, what are the difficulties? The difficulties is the inclination. The difficulties is the direction of scanning also. So this should become you cannot write, you will not end up writing the exhaustive coding for every activity, but these independent coding should automatically happen, right? But all modules would be available. That's what is the machine learning. All right. So here is another typical example. Okay, when we are running the text video, we take the video of the text, we move from one direction to another direction, which is normally the reading direction. If it is a all Urdu character, Urdu text, which is a direction, how do you decide about the direction? Suppose I have given it to my assistant and I tell him always scan from left to right. And if he scans even the Urdu documents from left to right only, how will you build up the entire text? That too for a real-time reading, let us say for real-time reading. Okay, so that's the important. And then when it comes to Chinese or Japanese character, it can be from top to bottom also. It is not from left to right, it can be from top to bottom also. So the direction of reading, how can you automatically understand? So these are all the interesting topics. So extending the same camera now, I shall take up to the next problem. So I shall use my camera, and camera should be able to tell me, my mobile should be able to tell me that it is a 20 rupees note or it is a 10 rupees note. But here in the picture that I have shown you, it appears as though the complete note is visible. It is not the complete note. You should take the problem in more complicated version, any soiled note, and just if I scan, just if I photograph a part of the currency note, then also I should be able to get with confirmation the value of that note. Okay, this will be useful for blind. Why blind? For us also, because even during the evening times, there is no sufficient light, and I will not be able to make out which note am I picking up and which note am I giving to the auto rickshaw driver or to the cab driver. Then I should be able to take the help of my mobile, and just mobile can scan it. Mobile camera can see that note any angle, any direction, and it should be able to tell that this is a note with the smallest amount of visible information to the camera. That is the target. Okay, that is where a lot of machine learning exercise has got to happen. And it can be any soiled note, any direction. See, the note has both the direction, any part of the note. Okay, so how much part should be visible, etc. These are the things which you have got to work out. All right, and more complicated ideas now because of COVID, when 2 or 3 people work from 2, 3 different places in a group. How will you coordinate with all these drawings? How will you pinpoint the drawing? And then these are the important machine learning activities that you should think of. This is with one set of text document. Now, I am going to give you another set of interesting examples. You look at this. Whenever a document is given to you, to a teacher like us, or to a lawyer or a teacher, what do? We just take a pencil and make lot of notes, isn't it? Underline and do it and write the meaning and edit it, do it. Lot of annotations will be there. Now my question is, if somebody has made lot of annotations, how will you remove all these annotations and recover the original document? I want to remove all these annotations and recover the original document. Okay, this is very much required. I cannot present a annotated document to the judge in the court, and similarly I cannot present an annotated document to be read by somebody else for his opinion. If I give an annotated document to somebody for his or her opinion, then the person will be biased to look at the annotation that I have already made. I do not want the person to look at those annotations. Then how should I automatically remove these annotations and give a annotation free document? So, well, we worked out this was some machine learning strategy. And you can refer to, if you Google, you will get some of my papers. So this is what is the annotated document, and these are only marginal part annotations made on the margin. Similarly, annotations could be made in the body. That's what you have got to think, how you have got to do. All right. See, here is next question. These are two different documents. Listen to this case study very carefully. These are two different documents. As the way I have selected, you can see this is a more faded document. Okay, it has faded up, and this is okay, much better document. The question is, are these two documents equivalent? Are these two documents same? The another constraint is, I don't want you to read these two documents. No OCR is available. Without OCR, you should be able to tell whether these two documents are equivalent or not equivalent. Of course, these two are not good copies. One of them is a very bad copy. Can you tell that these two documents are equivalent or not equivalent? Equivalent content-wise, structure-wise, organization-wise, in all respects. That's what is the equivalence to be done. All right, there are many reasons why we want to do this equivalence test. Now, I do not have time. If I deliver a lecture on equivalence of documents, then I shall speak about the motivations. Of course, this is again one of my PhD scholar, and then follow-up activities on my PhD scholar's activity. So here, there is a document, and here is a rescaled document, How will you establish the equivalence or otherwise between these two documents without reading the content, without applying OCR? Well, when it is English or when it is Kannada or when it is Devanagari, you may think of having the OCR, but even today, please note that there is no good OCR when it comes to handwriting graphemes. Handwritten graphemes are very difficult to be understood even today by the best of the OCRs available. You should understand that. Okay. There is scope for still larger scope for such activities. And now here, forget about using OCRs. We have got to just tell whether these two documents are equivalent or not. Machine should be able to do. If your human brain can think of solving this problem, machine should also be able to solve this problem. Okay. These are fairly good equivalent documents. These are almost ideally well-defined problem. Therefore, it should not be difficult. In fact, I should have shown this as the first document so that you could have really understood. But then I wanted to show the more complicated issues. The way what we did is this: we converted every line in the document into signals. Okay. We call them as line scan signals. Every line was scanned and they were converted into signals. So corresponding line was scanned and that was also converted into signal. But signal, now the question is, establishing the equivalence between the two documents is establishing the equivalence between the two signals. But the signal was so complicated, so much details. It's a big data problem. We converted them to some entropy computation. The amount of entropy computation itself was very huge. Then we converted into the histogram of entropies. Histogram of entropy gave enough condensation to deal with, but it was not enough. So we thought of the novel way of converting the histogram into regression lines. And then based on the properties of the regression line, we established the equivalence test. Okay, well, right, but then the machine should now automatically think of converting every text into some regression, and it should interpret the regression lines to tell whether the documents are equivalent or not equivalent. Well, you can find the references. Largely this work was initiated by Dr. Sahana Gowda, and later some other candidates followed up with this work. Okay, all right. Okay, now all these things are towards these copied answers. today, all your video examinations are automatically, they want to digitize it. And now the question is, if two people have copied, how do you find out that these two people are copied the answers? Like this question, whether this is copied the document of this document, whether this is a copied document of this document, right? That is the same question. But interestingly is this, in the case of copied answer, this is, let us say this is the original author of the answer. He is writing something about rose. Rose is a beautiful flower having thorns. For some reason, he wanted to cut off beautiful. Rose is for some reason, he cuts off beautiful. The person who is copying is intelligent. You should note that. He is intelligent. So why should he has cut off? Why should he write beautiful and then cut off? Then if he writes beautiful and then he also cuts it off, then it becomes makika maki. It is exact copy. But he is intelligent. A person who copies is more intelligent. Copying requires intelligence. So he writes without beautiful because he has understood that beautiful has been removed by the original author. So he understands that rose is a flower having thorns. Here there are 3 lines, 1, 2, 3. Whereas here he has condensed the whole answer into 2 lines only. All right. Then how will you tell that this is plagiarized or this is copied from this source? And how do you tell that this is the source? This is not the source. This is the source. How will you tell that? Okay. So here the size of the paper is totally different. Therefore, he has written it in 4 lines. He has also copied. Maybe he has copied from him. Maybe he has copied from him. But this is the original source. But he has copied. All right. Here is the answer. Without reading the content. See, my point is, can you be able to establish that these 2 documents are copied documents without reading the content? Well, we did some work, and here is maybe somebody else would be going to give more details about this. Okay, see, we enclosed it in the boxes. Irrespective of the change in handwriting, the corresponding position of the corresponding boxes should remain same, isn't it? And this part will not have the box at all. The sizes of the boxes will be different, but there shall be a correspondence. If it is a big box, this should be a big box. If it is a small box, this should be a small box. If it is a very small box, this should be a very small box. If it is a big rectangle, this should be a bigger rectangle. Like that, there must be correspondence. Is that okay? So will that work? That is what is the improved machine learning. All right. Okay. All right. So this is what. So the question of establishing the equivalence between the 2 document images have got the answer in detecting plagiarism, in detecting the copied answer books in the mass examination system. Okay. All right. Now, when I was speaking about examination system, the very first thing that in automating the evaluation or in going for the digital evaluation, if you were answer book, the first thing that you have got to do is arrange the answers in an examination answer book in the sequence of question paper, not in the sequence the candidate would have written the answers. You know, the way the candidate writes, the candidate takes some question to begin with. For example, here I have shown a candidate taking 5A to start with, and then he comes to 5C, and then he answers 2B, and later he answers 5B. So he will not maintain that sequence. Naturally, the examiner would love to evaluate the answers in the sequence of question paper, because that is easy for him to evaluate. And by evaluating so, he will also understand whether he has answered question number 1A, 1B, 1C, 2A, 2B, 2C, which questions he has missed, etc. He can really comprehend. But unfortunately, the answer books will not have that. But in the process of digitizing, can the machine make a learning, and can the machine resequence the answer book properly, resequence the contents in the answer book properly, so that digital evaluation could become a very easy job? That's a very interesting target, a very simple target, but a very interesting target. Now, well, let us assume that the question numbers have been properly documented by the examinee, by the students. And let us also assume that the question papers have been documented on the left side of the margin like this, and there is an explicit margin available. Then what should be our machine learning? Our machine learning should be to focus on this margin. Okay, I have to get only this margin aspect of it, and then split the answers. Okay, you do the segmentation of the answer, and then after segmentation, see, some part of the answer has been written like here, 5b is written here, 5a is written here, 5c is written here. Therefore, at least this 5b should have been brought in here so that the examiner can have the continuity of reading 5a, 5b, 5c. So first we have got to de-stitch these answers and then re-stitch such that 5b comes and sits here after 5a. That is what is re-stitching. So here I have shown that. So that this de-stitching and re-stitching is caused by giving the attention to understanding the margin. Okay, so learning has got to happen on the margin and the effect has got to happen on the entire answer. So that is what is re-stitching. Can we be able to do that? If we are able to do that, we can resequence the answer book in a more intelligent way so that the examiner will enjoy going through the answer book from question number 1A to last question. Okay, all right. So the next part is, if we can do this, can we present the whole answer book as a compressed answer book so that the examiner can do the digital evaluation wherever he likes to? It is not necessary that he should go for a central valuation. Now, another interesting point what I am telling is, one is compressing the document. Two, decompression has got to be done. But then why do you want to decompress the entire page? You should be able to decompress selectively only that line which my eyes are looking at. This is real machine learning. So automatically the system should understand on which line my eyes are focusing, and only that line should get decompressed. So only partial visualization should become possible. If that can be done, naturally I can read it on my small screen, anything, because I have got to read only that particular line. In case when I am reading, I want to recollect and I want to receive what was in this line, and my eyes will go up. Immediately machine should understand that my eyes have gone up and that line should get decompressed again. Is it okay? Quite interesting. You should do that. Can we do that? Selective decompression and partial visualization. That's the challenging problem with machine learning. Well then, as I said earlier, why should I read it? Can I make the machine to read it? Okay, if it is answer book like English, like Hindi, like Kannada, or if it is like a history answer book, then there is no point. Only in engineering answer books and science and technology answer books and in mathematics answer book, there are a lot of notations, lot of diagrams which an examiner has got to see. But if it is only continuous writing, like most of the engineering question papers are also like that, continuous writing only, explain, describe questions, will always expect you to write the continuous answers like this, running text. Then the examiner may feel, why should I read it? Let the system itself read the answer for me. I shall listen to the answer and then mark the answers. So then even without decompression, direct reading should become possible from the compressed file. So these are the interesting, challenging applications for societal applications. Okay. So I shall skip this particular part. Maybe I shall now. I shall tell about something about intelligent secretarial support. Having seen my secretaries, having been used to my secretaries, I have always felt whether I could come out with some machine learning gadget which can help my secretaries in very intelligent way. What does a secretary do? Secretary notes down the dictation. secretary notes down the points very quickly. All right. Sometimes secretary comes also with the dictaphone so that he will not miss whatever I have been speaking. Sometimes he will come with his mobile. He switches on his mobile so that he will not miss whatever I speak. He will note down and then prepare a letter. So for that, can there be a machine learning ability or a intelligent gadget possible? So there can be dictaphone files or in the notes taken in the shorthand, maybe Pitman shorthand, and there are many different types of shorthand. They take the notes in the shorthand. So this becomes the input. When this becomes the input, then when he is typing or when he is completing the letter, or when he is completing the document, these dictaphone content or the Pitman shorthand content will lead to word substitution. But while substituting this word, please note that domain plays the most important part. Like if it is a institution, academic institution, what type of domain it will be. If it is a doctor, what type of domain it will be. If it is an engineer, what type of domain. If it is a civil engineer, what type of domain. So that domain knowledge base, domain dictionary, domain words play an important role. Okay, domain knowledge base, and then special domain specific dictionary. Domain specific dictionary will help us to do the word substitution. Okay, right. Then phonetic knowledge base in Pitman shorthand or in dictaphone, phonemes are more important. The way you dictate the accent. So then phonetic knowledge base and phonetic substitution, phonetic dictionary will help. For example, I would have told ice. Then what ice? EYIES or ice, ICE, what ice should be there? So these are all phonetically equivalent. All right. So when they are phonetically equivalent, what has got to be the substitution over there? For example, when I have dictated a sun, is it SON sun or SUN sun? So that that comes both from phonetic dictionary and also from the domain dictionary. So that word substitution has got to be done. And then homophone substitutions. Okay, again there must be homophone knowledge base. Then text correction. This should automatically happen. So in the text correction, there are two things. Number one, grammar part of it. Automatically, now we have seen when we start writing, when we write an email, then automatically grammar support automatically becomes available, but still it is yet not complete. So grammar knowledge base for text correction, and then text organization. Well, I can write the text, but still it will not do a good organization. No intelligent system is available which tells put this paragraph above, bring this content of the first paragraph as the second content in the second paragraph, so that the composition becomes very good. So this intellectual part is still missing. It just becomes a material, and it will not tell break the paragraph here, construct a new paragraph from here, shuffle the paragraph, bring this idea over here, there is a line missing here, this is a gap in this two lines, add one more line. It will not tell all these things. So composition, the composition knowledge base, there is really a challenging problem. And if you can make the machine smart, work smart, like a natural person who is experienced person, then that is ultimate machine learning. So it is not just correcting every sentence with regard to its grammar, it is also organizing the entire text from the viewpoint of composition. If I can do it, then the deliverable text is wonderful, interesting, and naturally my secretary will be very, very happy. That's a very lovely, intelligent secretarial support. When you can think of an intelligent secretarial support, you can also think of intelligent OCR. So noise ridden text can be the input. Please note that in the earlier example I told, for handwriting even today good OCRs do not exist. And this intelligent OCR, again a concept of machine learning, extension of machine learning, it must be, it's because of noise ridden text. It is also because of text containing struck off words, like rose is a beautiful, in that example, rose is a beautiful flower having thorn. The beautiful is struck off. Then when it is struck off, automatically OCR should eliminate it from OCRing it automatically. And artistic text, like in the historical text document, handwritten text, these are all artistic text. So when I submit it to OCR, now the conventional OCR will show plenty of gaps. They show lot of gaps. They cannot OCR every content properly. That is where lot of machine intelligence has got to come into picture. So how will you fill up these gaps? How will you recognize these gaps? So you have to recognize these gaps, and then you should understand the context with the neighborhood. You have got to read the neighborhood and then understand the context. See, this is OCR, and OCR should understand the context and should understand the neighborhood. So the intelligence has got, OCR has got to become intelligent, and gaps will not occur at the regular, at the expected places. Some unexpected places the gaps will happen, and responding to such unexpected situation is what is the intent of machine learning. Is it okay? Machine should do that. Machine should respond. Is that okay? The pattern that a gap could exist is a possibility, but there is no regular pattern where the gap could exist. If there is a regular pattern, you can definitely write a code for that. But then where does the gap happen? How does the gap happen? What is the width of this gap? Nothing is known. That is where machine learning has got to play its role. Naturally, again, domain knowledge and domain dictionary, domain glossary of words would definitely. That is what I am telling. Domain, understanding the domain is more important. Okay, understanding. So the machine learning is responsive to a particular domain. So a domain, perfection in domain understanding is a necessity. Then gap salvaging can be possible, and then OCR output can be possible. This is the intelligent OCR. So intelligent OCR is next. I shall just take up this very interesting example. This has been my interest from a long time, but I have not been able to do much work here, except one candidate who was from Kashmir University who did. Unfortunately, this person who did such an excellent work also, passed away, died because of cancer problem. But that's a very interesting work. I could not continue this work much large. So this is, we fill up several applications. You see that we fill up several applications. The responses are different depending upon person to person. When you look at these two, you can really make out the printed part or the questionnaire is constant, whereas the answers are variable. So we are interested in understanding this variable part, which is the variant part, and we are interested in automatically preparing a database of this. Can we do that? Okay. So these are the different types of applications which you have, which are used to filling up various applications. In most of the applications, the responses will generally be handwriting. That is why I spoke about intelligent OCR to start with. All right, and now it can be generally handwriting. Now the auto filling of the application form straight away happens on the machine itself, because nowadays with the digitization, the application forms are also e-application forms. So at one end there can be e-application form, at the other end if it is conventional printed application form, then you have got to scan that application form, digitize that application form and bring it. So both of them now have become the e format, the digital form. Now in an application form there shall be a question, isn't it? There shall be some question for which your response would have been entered. So you extract a question. All right, you extract a question. When you extract a question, that should be transformed into a query. Note that. See, query is what you have learned in query languages in database. You will extract a question. What is your name? What is your age? Are you married or not married? Okay, these are the questions. What is your father's name? If you are a married lady, then husband's name, like that. So that should be extracted. That question should be extracted and that should be transformed into a query, because the answer has got to be automatically searched from a database. Okay, so it gets into a database and extracts the answer. It should extract the answer from a database. Is that all right? So many applications. Your engineering colleges will get many such application forms from AICT, from UGC, from your own management, from Government of Karnataka, from VTU. Several such applications keep coming. Now, can I load this application to the machine and ask the machine itself to fill up, because you have automated almost all the activities and almost all the details are available in the database. So why one has got to respond to every application form every time? Can it not automatically pick up from the existing database? That is exactly the adaptability by the machine. That is what is machine learning. The other interesting point is the examination application forms which are filled up by the students. So why every time the student has got to fill up the application form? Can you not fill up most of the details which are already available from the student database and ask him only to affix his signature, verify the contents and affix the signature? Does not the machine know that in which papers he has got to take the examination? Does not the machine know that he has paid the examination fees or he has not paid the examination fee? If he has paid the examination fee, does not the machine know what is the challan number? Why do you ask all these foolish questions when filling up a question, when somebody has got to fill up an application form? Can they not be automated? Because they are all available in the database. For that, extract a question, transform the question into a query. Query should get into database and it should extract the answer from database, and then it should automatically fill up. Okay, after it has filled up, it should prepare the entire template. So the entire template is prepared. Still I cannot trust it because it is still a prototype model which is under development. So now you validate this template, whether this has been properly answered or not. If the validation is good, well, you go for the production. The application form is filled up. If the validation, after the validation, you can update the database also, because while validating, what the things which were not available could be corrected. For example, there could be a question like the number, whatever it is, what is the number of children? Maybe in your database, still there might have been only one child. Now you might have become father of 2 children. Then you would have changed it. But that database should contain that. So now that after the validation, automatically take it for update the database. All right, update the database. All right, this is the bigger skeleton diagram for the machine learning. See here, where is machine learning? Machine automatically should extract a question and automatically should convert it to a query language, and that query should automatically search the database, bring the relevant answers. Okay, of course, validation is still a human computer interaction, but then preparation of the template, etc., should be automatically done. Okay, these are all the interesting part. Now I shall get into the complications. If application format is pre-known, generally pre-known, same application form is repeated again and again, then it is a pre-known application form, in which case you need not even read the question. You can just straight away enter it, the answer. Like you have seen people sitting near the Altibo offices, they don't even read the application form. You go to him, you tell, he keeps on asking you, you respond, and he keeps on entering into that form even without reading the question part of it at all. So the application format is very, very pre-known to him. So under the pre-known condition, it is a supervised filling up the application form. All right. Then if the application format is not known, then you will read the question. When you read the question, then it is unsupervised. All right. So you have got to read the question, understand the question, and then fill up. Then it becomes unsupervised. So the simplest form, the simplest automation is with supervised situation. More complicated is with the unsupervised situation. If searching has to be done from multiple databases, suppose you have multiple databases, right? Like your resume in one place and some details in some other place, some other database and some other database. If searching has got to be done from multiple databases, even then you should be able to do that. That requires smart searching. That is what is smart machine learning. Okay, and then concurrent searching. It is not one after the other. It has to get into all databases where possibly the answers could be available. It should get into concurrent searching and should be able to bring all the answers. Okay, then if inference has to be drawn to find the answer, answer is not directly available in the database. Answer has got to be derived from the observation. So your query now should be suitable enough. Question can be something else, but the query should be in such a way that it must be database friendly, because it has got to pick up relevant inputs from the respective databases. But those inputs are not the real inferences. You have got to derive the inference. Can you put machine learning there which can draw this information and generate the knowledge, which is the inference to be filled up there? That is what is the real part of solving the problem. If inference has got to be drawn to find the answer to that query, how it has got to be done? It is an advanced interpretation. Okay, should understand which data will produce this information. All right, suppose age as on this date, whereas your database will give you only date of birth. Okay, here what is asking is age on the date of application form. So age has got to be computed. All right, it is not the height, it is the age. That is what it has got to understand. Now other complication is if human computer interface is required. So many times our database may not be able to give some particular answers, then human interface is very much required. Then if human computer interface is also required for filling up the application form, what has got to be done? It has got to be more intelligent learning. If database is unstructured, very unstructured, like a resume of the person, if like a resume of a different individuals. So Dr. Sharmila may prepare a resume in a different way. Dr. Purnima Shetty may prepare the resume in a different way. Different people produce their resumes, but then I have got to extract some content from all of them. Then how to fill up the application forms. These are all very interesting problems. I have chosen those problems which are seen, which are felt, which are present around us, which need a greater attention, because these are the problems which need the solution to enjoy, to make an enjoyable society. I shall not get into these. There are many applications which I have listed. I don't get into this now. At the point of time now, I will leave it here. There are many interesting issues. I shall leave at this point, and I just tell you a thank you. We shall interact. Thank you, Dr. Sharmila.
Thank you.
Yes.
Thank you, sir.
Thank you.
Thank you. Thank you very much.
A wonderful keynote address, sir. So
Thank
now, before moving to the question and answer, sir, there is a special clarification from Professor Guru D.S. Mysore. So the first question for this session is how AI and ML plays role in the field of IoT technology.
Oh yeah, see, this is very interesting. Internet of Things. What is Internet? It is connectivity. Now, when human brains also can get connected, more than one. I have given you just now I have given you one example. One example is connectivity amongst several databases. So it is Internet of Things also. It is a connectivity between several devices, various devices. Now, why intelligence is required? The intelligence here is required to I understand from which device can I get the response, to which device, from which sensor can I be getting this particular data. Even to understand that, the knowledge is very much required, and it has got to be spontaneously generated knowledge. Okay.
So the role of supervised machine learning in modern business.
Olaf?
Support.
Supervised learning in modern business.
Machine learning.
See, what is supervised learning? In supervised learning, every activity is already pre-labeled. It is pre-labeled. The effect, the excitation is known, the cause is known, the response is known, everything is known, and that is a supervised representation. But when such pre-labeling is not available, then it is unsupervised. If the supervised, if the labels are available, or if the learning material is understood for what it is employed, for what purpose it is employed, and what is the outcome of that, then it is supervised activity. In the absence of supervised labeling, in the absence of labeling, we have to go for unsupervised. I'm very sure, I think there is cluster analysis and classification. These experts would make it more elaborate at that point of time.
So next question, how India can efficiently use machine learning and beat top countries like America and Japan?
It is not the question of beating anybody. It is a question of using your natural intelligence. How brainy are you? That's all. Okay. And now it is not India, it is not Japan, it is not America. It is all collectively. It is a sort of internet of all of us. Okay. We have got to work together. There is no question of beating anybody here. No, we don't want to beat anybody here. We don't want to show that we are superpower. We have got to work together. All right, but we have the capability, and obviously India has been very well known right from the beginning for its capability in information technology, and India is in fact studying it from the geographical perspective and intelligence perspective. India is a land of natural intelligence. The geographical location of India is so congenial for promoting the intelligence. Therefore, the natural intelligence that we are blessed with should be able to imagine all the situations which possibly the dull heads like me may not be able to imagine. So that imagination that I can do should itself be a key, a turning point that can I make the machine to do that. Therefore, all of us are equally competent, and well, as far as computing power is concerned, today India is also not inferior. A lot of computing power is available, and indigenously invented computing capabilities are available in India. So India there should not be a sense of such competition at all. It is all working together now. All right, we work together. We shall work together. Okay. So India can make a very good dent, can make good contributions.
So when we already have a pattern matching policy, rules and image and video processing in forensics, how will machine learning be used in forensics?
See, policies are present, but the application of foreign policies are, in other words, yes, which policy should be applied where, and what sort of data should I apply which policy. This is where automation is required. Okay, it is not. See, the advantage of automation is concurrent processing of all the policies, whereas even the best human expert, though can be able to access to a policy, can lay his hand to access a particular policy because of his intelligence, yet the trying of every policy or trying of the possibility of every possibility still becomes sequential. Whereas with a huge computing power, you can always think of a concurrent processing. That is where automation is required. See, automation is required when amount of data to be analyzed is very large. Okay.
So the last question, that is, if we have 20 data sets only, so can we complete the research work efficiently?
See, research work is about coming out with a new idea, right? I have got to tell you the example of Polly Wiener's PhD thesis. Polly Wiener wrote a PhD thesis on realizability. All right. And do you know what is the size of this thesis? The size of this thesis is just half a page. And for a half a page PhD thesis, he got a PhD degree awarded. And it is not 20 or 10 data. Somebody can work without even data. All right. In fact, when Dr. D.S. Guru, Dr. Shekhar, these people were working with me, there were no proven data sets available, huge data sets available. We had to create data sets. But the type of complexities that they were able to think of and they were able to present with few examples were good enough that even the great critics were able to appreciate their work. So it is not the data of 20 which is important, but then the diversity in the 20 and the complexities that you can represent through the 20 is more important. But it is not, the 20 is not a heuristic number, or 20 is not a magic number that can make you a PhD possible. But the diversity of the data and your ability to apply on different varieties of data has got to be demonstrated. And today, today a lot of databases are available, a lot of complexities are available. See, the whole idea is how generic could be your solving procedure. Naturally, what is the amount of the stretch of diversity of data that your hypothesis can handle is more important. You have got to illustrate this thumb rule, whether it is 20 is enough, 10 is enough, 100 is enough, is not enough at all. For an intelligent boy, only 1 year is more than enough. For a dullhead, even 10 years may not be just sufficient. What can we do? All right. So don't ask such questions. Your guide is the best person to tell whether 10 is enough, 1 is enough. And can you write a thesis even without data? Why should you write it? After all, idea is more important for a good PhD. Generate a good idea, come out with a good idea, show that irrespective of the data, my idea should work. And you should definitely get a PhD. All right. You don't need even a computer to get a PhD in computer science. All right. Okay.
One last, sir. You
Yes.
have worked in college and university, now in National Institute. So
Okay.
can you comment on facilities, quality, research, minds, freedom?
Yep. See, one, your brain is your property. And your brain in a democratic country like India is very free. So any able brain which can think, irrespective of the place, shall think and will do the job. Definitely will do the job. And naturally, for a very good research in computer science today, the place is not very important. After all, today, good internet connectivity, good brain, and a good processor, good machine. These three are enough. So if you can sit at home also, you can do without any affiliation to any university, etc. However, with advanced facilities, as far as advanced facilities are concerned, naturally national institutions of importance have come with, they are the credentials of the advanced, they are the objectives of advanced institutions of national importance, because the whole importance is that the research is the first criteria and researcher should be able to do the teaching. And that is why in the new education policy, it is said that all these institutions of national importance will become research intensive institutions. Okay, research intensive institution does not mean they keep doing only research. It also would do teaching activity, but researcher will be able to teach. Universities surely are better places also. Then I am not telling that colleges are not better places. In fact, I was in a college also, and then we have seen that we have developed very good research laboratories, research infrastructure, even at SJ College of Engineering. Where there is a will, there is always a way. Okay, the institution shall not make a big difference. But then surely affiliation with an institution will have its own value. Surely, just because if you are affiliated to a IIT, if you are affiliated to a triple IT, or if you are affiliated to a very good institution, that affiliation surely carries the weight. But on the contrary, your presence in that institution, your quality of work in that institution should raise that institution to that level of an IIT, to that level of triple IT, although that institution may not by itself be IIT or a triple IT. Okay?
So here we come to the end of the question and answer.
Yes.
So it was a wonderful keynote address, sir. A great
Thank
session
you.
on machine learning for societal applications.
As you saw that I had to stop halfway through, and 50% of my slides are still just not covered. I had listed several societal applications. Okay.
Okay, I, Professor Mohammad Hafiz MK, on behalf of Department of Computer Science and Engineering, EA College of Engineering, extend the gratitude on having Dr. P. Nagabhushan as the speaker of the session. So there were a lot of takeaway from the session. I'm sure our participants have benefited a lot from the session and received valuable inputs to channelize and fine-tune their research work. So thank you very much, sir, for sparing some time from your busy schedule. So we are really grateful to you, sir, and we look forward for your kind support and cooperation in our future events too. Thank you, sir. Thank you very much.
Thank you very much. Thank you very much.